I
Yeah,
stumbled across you on a documentary about tsunamis, and you've been studying tsunamis for a very long time. But
yeah.
how did you first get introduced to the world of tsunamis?
Good question. I was doing my PhD at Caltech in California, and uh, at the time, I mean, this was late '80s. Tsunamis were not happening, and it was and essentially worked with mathematical analysis and computer modeling of tsunamis. And then in 1992, it was what we call the first modern tsunami, September 1, 1992 in Nicaragua. And then I went out on the field and I realized that everything we were doing, back in the lab and in the analysis was all, well, not exactly wrong, but uh, pretty much, not relevant. I mean, the real world was so much more complex, and we had to pay attention to the real, to real hydrodynamic, water phenomena that we're simply not accounting before in our, computer models. And I also realized that how much more information you could get from eyewitnesses, people that had actually just lived through this, extreme event. So pretty much, I started the field of tsunami field surveys and extreme event surveys. At the time, in around the world, there were very few tsunami experts. Uh, I learned a lot from the Japanese teams, but in the United States, I mean, I was pretty much the only person that was working with, doing field work, going systematically in every and literally in every tsunami that was happening. We developed a capability where uh, as soon as a tsunami happened somewhere in the world, within 2 or 3 days, my team, myself, and my students were essentially had a very gung ho attitude. Let's go for it. Let's go there, study it, talk to the people, make measurements. What measurements? I mean, make measurements of how deep the flooding was, how far it had penetrated inland. So this is what was extremely important information, as well as the stories from the people. So that's how it started, and then from there, and we started literally to this date. There hasn't been a single tsunami since 1992 that myself or my students we haven't been out to really record and study.
Yeah, it's fascinating. For those people that don't know what a tsunami is, can you break it down? How is a tsunami formed?
Okay, a tsunami is a really long wave that's formed by a deformation of the seafloor. So if you have an earthquake, the seafloor lifts up, and that moves an incredible amount of water. Is very different than wind waves. Wind waves are generated because the wind blows on the surface of the ocean, so you have these waves that are generated, and it sets into motion. It disturbs maybe the top 30, 50 feet of the, or, meters, the top 10, meters, maybe 15 meters of the water surface, as opposed to a tsunami, exactly because the seafloor moves, it sets into motion the entire water surface. So the entire moves up, and then the tsunami starts propagating in all directions, and that creates a fairly, when I'm saying long wave, in the deep ocean, a tsunami can have a wavelength, meaning the distance between crests of the order of 100 kilometers. You can talk about, let's say, a wind wave, the kind of waves that you surf. I mean, if you have a wave that is, extreme wave on the coastline, let's say wind wave, its wavelength is almost never going to be longer than, a kilometer. In most cases, 50, 100 meters. And this is for really big waves. Now, multiply that by a factor of almost 100, and you get what a tsunami, what a tsunami is.
Yes. And what some people get confused between a tsunami and a tidal wave. They're completely different, aren't they?
Well, not yes and no. So in the beginning, we used to use the term tidal wave, and I'll explain why. In the Mediterranean, where there were the first references to tsunamis from the ancient Greeks, going back to Herodotus in 472 BC, the tsunamis manifested themselves not as a moving wall of water, as you have seen, let's say, in the pictures from Indonesia in 2004, Japan in 2011, most recently in Indonesia again in Palu. But basically, it looked like a very fast rising tide or a very fast receding tide. So the ancient Greeks were describing this phenomenon, which they had correctly associated with the earthquake, but they were describing it as essentially a tidal wave, meaning this very rapid wave that looks like, as I said, a fast receding or a fast rising tide. So we used to have the term tidal wave, but then there was confusion with the tides. I mean, tides are also waves, and they just have very, very long periods, like 12 hours. So eventually, the Japanese term tsunami prevailed, and of course, in Japan, most tsunamis do not look like fast rising or fast receding tides. I mean, they a lot of times they look like walls of water that are coming in huge breakers that are advancing. So right now, we no longer use the term in the scientific community tidal wave. We use tsunami.
And how many known recorded tsunamis have there been in the last 100 years?
Uh, I can tell you that in the last 30 years, we've had on average, pretty much one tsunami somewhere around the world per year. If you look back in the last 100 years, it's hard to tell because at the time, there was not as much reporting. Only the really big tsunamis were being reported. And the reason being is that, let's take the tsunami in Papua New Guinea in 1998. Huge tsunami reached about 15 meters, that's 45 feet high, in the north coast of Papua New Guinea near Sisano, that's a little bit west of Wewak, killed about 2,200 people. Um, Pretty much the world community found by, sorry to say this, by accident. So happened that the helicopter was going into a logging plant, looked down, saw this damage, said, "Oh, this looks unusual." Um, you know, they hovered around. They realized that the catastrophe had taken place. Had this been taken place 50 years ago, nobody would have known. So, uh, in terms of large events, for most of the century, when I'm seeing large, really catastrophic tsunamis, we've had about one every decade. Uh, in the last 30 years, we've had about one per year.
Wow.
But
And
it's the
it's
difference in reporting. I mean, the last 100, if we're looking at the 20th century, most of the moderate tsunamis and the small tsunamis, they were not being reported because, they were in
yes.
remote areas and nobody knew about them. You really had to have something that was basin-wide, catastrophic, or was close to a big city where there were news media and reporters and, they reported the catastrophe around the world.
Yes, and you did mention too, Professor Costas, of the 2004 Indian
Yeah.
Ocean tsunami.
Yeah.
What made that event so catastrophic?
Well, 240,000 people died, and the what made it catastrophic was that first of all, there was no, uh, it was one of the reasons that it caused so many deaths was the fact that there was absolutely no warning. People were caught completely unaware. There had not been a really big tsunami in the Indian Ocean for decades, if not, centuries. And there was no, in most places, except perhaps the Andaman Islands. These are islands off Sumatra, where there was ancestral knowledge, and some of the native inhabitants knew that if the ground shake, they had to move to high ground. In most other places, in Indonesia, in Malaysia, in Thailand, in India, in Sri Lanka, in the Maldives, in Eastern Africa, nobody knew about tsunamis. There was absolutely no awareness. So, uh, so these two things: one, that there was no awareness, and there was no warning. For example, in Thailand, the tsunami arrived about between an hour and 2 hours after it arrived in Banda Aceh in Indonesia, which was ground zero. Banda Aceh is the northern tip of Sumatra. Sumatra is just south of the Malay Peninsula. So there would have been time to evacuate the beaches in Phuket and in western Thailand. The same thing with Malaysia. Then the tsunami took several hours to reach the eastern coast of India. There could have been time to evacuate people, or at least have a warning. The same thing with Sri Lanka. About 30,000 people died in Sri Lanka. And had there been a warning, I mean, I'm pretty sure we would have had a very, very small fraction of those deaths. So I think what made the Indian Ocean tsunami unique was the fact that, first of all, it was the first time, around the world that people realized that this was really a very, very, very serious natural hazard, and that big earthquakes can generate really big tsunamis that can spread basin wide. And this tsunami affected the entire Indian Ocean. It was not just a local phenomenon that would affect the earthquake happened off Sumatra. It would just affect the people in Sumatra. It affected the entire Indian Ocean. So this was the first time people around the world came to this realization, and since then, it sort of kick-started the era of having and establishing tsunami warning centers. There are now a few tsunami warning centers in the Indian Ocean, as well as in the Mediterranean. I'm pleased to say this was the trigger to establish the Australian Tsunami Warning Center, which is one of the best I think the most credible in the region, and certainly along with the UNESCO warning centers and the American warning centers, I think the best warning center in the world. These are the three best warning centers: the Australian Warning Center in Melbourne, and the Warning Center in Hawaii, and the Warning Center in Alaska.
Yeah, and the amount of energy that that earthquake produced was incredible. I mean, how could you describe that energy of that earthquake to produce such a huge tsunami? I mean, like worldwide, it was just like, what would that
Yeah,
equate
it
to? How many
actually
atomic bombs would that be?
Uh, it's I don't know the I'll come up with a number, but I can describe it to you in a different way. I mean, certainly uh, hundreds of Hiroshima atomic bombs in
Oh
terms of the
my
energy. But
God.
I mean, just imagine a chunk of land that's about close to do you think in miles or in kilometers? What would you
Kilometers. Yeah.
kilometers. So just imagine a chunk of land about 1,000 kilometers long that moves, is uplifted by about 20 meters. So, and, about 50 or so kilometers width. So you have 50 kilometers by 1,000 kilometers, you know, lifting all this up by 20 meters and generating, and very, very rapidly. So you generate, a huge wave. You have a tremendous energy that goes into this. Uh, Also because the and it is very, very close to the coast. I mean, the communities there were sitting ducks, particularly in North Sumatra. I mean, the wave arrived within 15 to 20 minutes. Uh, uh, Even with warning there, unless someone had started moving off the beach immediately and running inland, the wave penetrated about 4 kilometers, 5 kilometers inland. I mean, and when I'm saying penetrated, with a height of about almost 2 meters, imagine being about 3 kilometers inland and seeing this wall of water coming towards you, which is about 2 to 3 meters high, and you're 3 kilometers inland. So they didn't have. Um, this is why 180,000 people died. To give you an idea, 9 out of 10 of the people in the region, in the flooded region, died. 9 out of 10. So people didn't really have a chance.
Oh my God. And it's terrifying just to think. I saw the footage. The footage was just terrifying to actually, put yourself in a situation. I did see some footage of a man standing on the beach in Thailand, and the wave just completely engulfed him. It's just terrifying. So, how big are we talking about? Some of the waves that struck Sumatra, Indonesia, Thailand, India. What was the run-up height for some of these waves that struck those coastlines?
The maximum that we measured was about 40 meters. So this means that the
40
wave
meters.
climbed to an elevation of 40 meters. Just to give an idea for our listeners, I mean, if you look at the high rise, 40 meters is, I mean, almost like a 10-story structure, 10, 11-story structure.
Oh
So it
my
went
God.
all the way up. So if you were on the beach, a little bit further inland, I mean, this is, the run up, you had to climb up. Uh, the sad part was that in some places, particularly and this was in Sumatra, in northern Sumatra, in some places there were hills close by. So if people could have um, you know if they had warning and they knew where to go, and that's important, they could have climbed up on the hills right at the shoreline. And this is when I'm saying this is a run-up, this is how far the wave reached. But at the shoreline, and we have measurements, the wave was about 8 meters high. The wall of water coming in, that's 8 meters. So again, it's like having a two-story, you have a wave that's coming in, it's a two-story structure. And I have to say this thing, James, which is important for people who surf. People who surf think like, what's the big deal? A 10-meter wave, you can have the storm wave, I can surf it. No, this wave is extremely long. So a wave that you surf will come in, splash, it's a big wave, it will run up, it will come out. This wave keeps coming and coming and coming because it's a very, very long wave. It carries with it a lot of water. It's not, I mean, a 10-meter tsunami at the shoreline is vastly different than a 10-meter surfing wave that someone can surf, exactly because the wave keeps coming and coming and coming. And this is not the kind of wave that you want to be in. And, you want this to come and, you have a long run because you want to surf it all the way. You can't because the way that it breaks, it's entirely different than the way that a wind wave breaks. I mean, here you have essentially, there's no other way to describe it in simple terms, a giant change in the water level. And suddenly you get, I mean, it's within literally, a few seconds, sometimes within a couple of minutes. I mean, you're going to get from 0 to 8 meters, just like that, and the wave, will keep going. So it's very different than a surfing wave, and there is because of the quantity and of the wavelength of the wave. The surfing wave, I mean, in comparison, is going to be about this width. I mean, the same scale. The tsunami is going to be longer than 5 or 6 times my, how as far as I can stretch my arms.
Yes, yeah. And the footage also as well, Professor Costa, in Japan,
Yeah,
that was pretty terrifying as well. I think I heard some of the waves on the coastal lines were reaching around 40 meters.
indeed,
And
it is true.
there's some footage on YouTube. You can actually go have a look and you can actually see there's footage from the ground level of the actual wave coming in. And it's
Yeah.
like terrifying to watch. It's like something out of a natural disaster movie.
It's a,
And you've done a bit of field research as
I spent
well.
quite a bit of time in Japan, just as I've done in Indonesia. Yes.
Yeah, you've done some field research. What's been the most haunting thing you've witnessed from the ground?
The most haunting thing I think was in the um, first of all, in Japan, I mean, which was a huge catastrophe, you would find, I mean, the wave again penetrated in some places about 3 kilometers, 4 kilometers inland. Basically, no sounds. I mean, you go there, there are no birds, there's nothing. I mean, it's dead, the silence. The silence is deafening. In Sri Lanka, uh, and it was different. And I'll tell you, I mean, this is a place that, to me, it was incredibly moving. And the reason is that the wave didn't penetrate that far. People died, but they were uh, some. I mean, when I was there about 3 days later, there were still the relatives and some of the survivors that were looking for their loved ones. Um, and I mean, it was clear that the, uh, they were still in denial. They couldn't fathom how this could have happened, and they couldn't fathom how they could have survived and their relatives and their loved ones did not. And then there was so much misery. I mean, to just see the people lining up to get rice, to just the world community had not really. I mean, it took several days to have huge relief effort getting in. So in the first few days, I mean, you were still looking for survivors, and people were just moving around kind of aimlessly, trying to understand what had just happened. And I was with a team. Probably I was the most experienced, but I was with a team of scientists. We were in a van. There was four of us, and as we walked, and as we drove around, place after place, suddenly, spontaneously, people started crying. So they started crying. I mean, adults, etc. Because what you saw was, people have, different sensitivities, but one way or the other, you would see something that it hits you. I mean, that this is something that's just, oh my God. To me, the moment was, I was walking there, and there is a white wedding dress that's about 5 meters high, up perched on a tree. Why was a wedding dress perched on a tree? Why was it 5 meters high? Because the wave had come in, it had carried it, the flooding, and had left it 5 meters up on a tree. And you can imagine, I mean, the story of two people, probably, if there was a wedding dress there was a wedding, etc., because there were other things, and the wedding gets interrupted, and the wedding dress ends without the person up on the tree, and who knows where the person wearing the wedding dress is. But what happened? But there are things like this that you go into the field that they're completely, they stay with you. In terms of run-up, I mean, clear destruction. It was in the Krakatoa eruption in late 2018. That was about 7 years ago. Um, in the islands just south of Krakatoa, there the run-up was about 80 meters. 80. 80.
Wow.
So we were in a little boat just off the coast of just off Krakatoa. We're hoping that we would not get another eruption because we were in a really small boat. And we were trying to estimate, because it is incredibly difficult. Usually we go on the ground, you hike, but to hike a vertical cliff that has fallen off, and it's just, it's landslides, etc., that's 80 meters high, is extremely difficult. So we would land, go in, but in terms of just being impressed with the power of nature, just seeing this, the wave going all the way up to 80 meters, that was stunning, astounding.
Wow. Oh my gosh. So you actually saw the actual wave coming in?
We didn't see the wave. No, we didn't see the
No.
wave coming, but we saw the impact of the wave. We saw it because it's very. What happens, James? It's extremely when you are there. It is fairly easy to see how far the wave penetrated, because basically everything that has been flooded, dies down, and also it's the erosion. As the wave climbs up on the slope and comes down, it carries with it trees, etc. So you can see the tree line, you can see there is a trim line, you can see the trim line. Everything below it has been flooded, everything above it, and this is how far the wave reached. And then on one island where we could actually, climb and go up and see it, you can see it. I mean, you can find up. These are some of the islands south of Krakatoa. Krakatoa is in the Sunda Strait that's between Sumatra and Java, that generated a huge tsunami and a huge eruption back in 1885. It was a very famous movie too about Krakatoa. The movie says east of Java, but it's actually west of Java. The So you can climb up and you can see it. And I mean, some of these islands are not are inhabited, and you see all sorts of plastic debris, etc., that has been washed up 80 meters high from the from the tsunami.
Oh my gosh, that's terrifying. What is the world record for the highest tsunami ever recorded?
uh, the world's record for the highest tsunami, that's close to uh, 500. Hold yourself, 500 meters. That is in a
500
fjord.
meters.
Yeah, that's a fjord in Alaska.
Oh my
And
God.
what happened was one side of the fjord slid. I mean, it was like a glacier. And as it slid into the fjord, there was a big earthquake. So when the earthquake happened, it detached part of a glacier. So think about the fjord that's like this. So the glacier comes down and basically pushes all the water on the other side. It was sheer luck. I mean, it was in a glacier in Lituya Bay that there were no people nobody who lived there. The reason we know about this, there were some fishermen that were outside and actually experienced the wave. By the time the wave actually came out of the fjord, it was not that big. The people survived it. I mean, there was a fisherman who actually thought, and they saw that this was what was happening. They didn't really see how high it went, but these are the ones who made the report, and that's how geologists, a very famous geologist, George Plafker, went there. And, years later, I don't think anyone went there contemporaneously, but people went there, years later, and they realized, my God, what had happened here? I mean, this had happened back in, I think, Lituya Bay was 1953 or 1954. So, I mean, it was not easy. These places were not easy to access.
Yeah, and they call that a mega tsunami. Is that
That is a
correct?
mega tsunami. That
A
is
mega
as
tsunami.
mega as it gets, yes. And
Yeah.
they're not that rare. Back in 2016, there was another one, again from a fjord, again a glacier sliding down. And the tsunami in that case, if memory serves, was about 300 meters. The run up on the other, but it was very, very similar again. The glacier falls down on one side, pushes water on the other side of the fjord. This is a huge concern, by the way, in Norwegian fjords, etc. What would happen if you have a glacier? Because a lot of Norwegian fjords, as opposed to Alaskan fjords, you have small towns and villages. But pleased to say that the Norwegians have developed a fairly good warning system, so that if there is ever going to be, well, they think and they do their best to have detection systems. So if there is ever going to be a glacier that's about to slide, or you're going to have a huge landslide that's going to threaten coastal communities, they have a warning system, and we hope that's going to work, because if it has to work, James, the incredible thing, this thing has to work the first time, and it has to work perfectly. I mean, there's no other way. I mean, if it doesn't work the first time as designed, that's it. You lose people. So we hope it's going to work, and the Norwegians are doing a great work trying to.
Yeah. There's been talk of a potential mega tsunami from the Vieja volcano. Um, how realistic is that scenario?
Okay, the scenario, the collapse is realistic. What has not been realistic early on. People made some wacky, ill-informed uh, statements that the tsunami would come in and would wash over the Florida Panhandle. There's no question that a tsunami like this will have impact across the Atlantic Ocean. No question about it. It will impact the Caribbean islands, etc. What happens is when you have a tsunami that comes in from a caldera or from a sector collapse, and part of the volcano just. So this is a huge landslide, Lituya Bay size. Locally, the tsunami is going to be very big. I mean, if you are, a few kilometers away from the islands, from the Canary Islands, probably, the change in depth is going to be, hundreds of meters. No exaggeration here. But because the wavelengths of these tsunamis are fairly short, what happens is that they The correct word is disperse. They change forms very, very rapidly. So as they will propagate, as you know, across the Atlantic Ocean and make it all the way to the Caribbean and all the way to Florida, the height will diminish very, very rapidly. The wave will start breaking up into smaller and smaller waves. So the leading wave, the one that's going to reach Florida, is probably not going to be, I don't know what the most recent calculations are, but the way that's reached Florida is not going to be, much bigger than about 10 meters or so. It's going to be a horrible wave, no question about this, but it's not going to be like, people thought in the beginning. It's going to basically completely grow over. I mean, Florida has some mountains, etc., but the tip of Florida, the South Florida, is almost like a sandbar, maybe it'll go over, but and even 10 meters, that's the 10, 15 meters at the shoreline, that's the worst scenario. Most people think that it's not going to be, a realistic scenario. Yes, the collapse is realistic. It could happen. In terms of the impact on the Western Atlantic, it's not going to be as big as people had feared. There's going to be warning, ample warning. I worry more about the impact in uh, Northwest Africa. No, I was saying the impact on the Eastern Atlantic. This means no. As you look at the Atlantic, yeah, the Western Atlantic side, that's Florida and the Caribbean. The impact now on the Eastern Atlantic. I mean, if you look at the west coast of Africa, that's going to be slightly, it's going to be more. It's just that people don't study these things anymore. They are very, you know, let's face it. I mean, tsunami science early on, because of the funding, etc., was very Western society centric, and I mean, it was thinking about whether, and this is partly why the Indian Ocean had not been really extensively studied as a source of big tsunamis, because there were no Western cities that were at risk, and people, there was no funding to do this. People didn't study them. Um, you know, as far as Western Africa is concerned, I don't know how many people are really studying the risk from or what might be the impact from such an event.
Yes. And I have heard also that there's a fault line from Southern California that runs from Oregon through to Washington. I think it's called the Cascadia Subduction Zone,
Yep.
and that apparently is a ticking time bomb. Um,
Well,
is that a bit of a worry? Will
done your
that?
homework. You've done your homework, James.
I have.
Yes, it is a big ticking time bomb that can generate earthquakes up to magnitude 9. That's called the Cascadia Subduction Zone. It is where the Pacific plate gets subducted, means goes under the American plate. That's why you have in that region big volcanoes. Typically, anytime you have a subduction zone, the way it works, you have the plate that goes down, and then the upper plate moves up, and then you have volcanoes, because as this plate goes under, it heats up, melts, and all that material from the plate that gets subducted returns to the surface through a volcano. That's why in the Pacific Northwest, and you're absolutely correct, all the way from uh, South Alaska, uh, you know, the entire west coast of Canada, the Pacific coast of Canada, and starting in from Northern California, going all the way to Southern Alaska, you have this very, very long subduction. And we know that it has big earthquakes pretty much every on average, people think on average every 300 years. And the last one was on 1700. So if on average a big magnitude 9 earthquake happens every 300 years, and the last one was 320 years ago, 325 years ago, we are overdue for
Oh,
a big for a big earthquake. So that's why you referred it correctly as a ticking time bomb.
oh my God. So, and how close is that fault line on the coastline? Because if I remember correctly, that runs from, I think, all the way up through to Canada. Is that correct?
Yep. Yeah, yeah,
and
yeah.
then Oregon, Washington,
So,
all the
goes
way down.
right. It is. I
And
mean, it's very long, and it depends. I mean, when you have a magnitude 9 earthquake, it's probably going to be about 1,800 to 1,000 kilometers long eruption. The
wow,
reason is you can think, I mean, an earthquake rupture is very much like opening a zipper. The longer the zipper, the bigger the earthquake, the longer the tremor lasts. Like in Sumatra, 2004, the tremor lasted about 6 minutes. Japan, about 4.5 minutes. I mean, these are huge times. I mean, imagine for 4.5 minutes being shaken. To give you an idea, this morning there was an earthquake in the south of in the Aegean, between Turkey and Rhodos, the island of Rhodos. Magnitude was about 5.8. Shaking was about 6 to 7 seconds. Imagine something that shakes for 6 minutes. So
terrifying.
it's exactly because if you think of the zipper, as you unzip it, it takes longer for the fall to unzip. So the longer it takes, the more shaking it produces. So in the Pacific Northwest, I mean, it's the rupture is probably going to be about 1,000 kilometers long. So it depends where it is centered, whether it will start from essentially just north of San Francisco in Northern California, or whether it will start just south of in South Alaska. But where I mean where the tip of the rupture is. But most people believe that the tip of the rupture is just going to be off northern Oregon, or somewhere there off northern Oregon. I mean, not the tip. That's the epicenter, just offshore. But this is going to be a huge event, and there are many, many, many coastal communities in Oregon and in California and in Washington, not to mention British Columbia. I mean, you have communities everywhere. The good news about that event is that there is a lot of preparedness. There has been, I think, in terms of preparing for a big earthquake and a big event, the Pacific Northwest is probably, along with Japan, the best prepared communities in the world.
Oh, that is good
Yeah,
news.
it's very
Yeah, that is good.
good.
So, if the earthquake that's generated around a 9 on the Richter scale, how big do you think those tsunami waves will be along that fault line?
Easily, I mean, by the time they reach the shoreline, they will be Sumatra or Japan. I mean, they will reach run-up of the order of 30 to 40 meters easily. When the wave gets, I mean, the time it reaches the coast, it's probably going to be at least 5 to 6 meters high. And again, think of the wave, not a surfing wave that's coming in that you can surf. I mean, a change in the water level that just moves in like a wall, like this. So, and then once it reaches in, I mean, it may be 6 meters here, but if it reaches on a hill, it will climb up all the way to 30 or 40 meters high. So it depends on, where exactly it is. I mean, it's very hard to sort of, but ballpark figure, this is what we're talking about, 30 to 40 meter run up. I mean, it's how high the wave will reach, and about 5 to 6, you know, uh, meters at the shoreline.
Yeah, and I did hear too, Professor Costas, that it is quite hard to predict when a tsunami will happen. You know, you have early warning systems and things out in the Atlantic Ocean, Indian Ocean, Pacific Ocean, but they are very difficult. You can't actually predict when the tsunami will happen. But can AI, like artificial intelligence and things like that, could that help people be a little bit more prepared?
Uh, Let me tell you, uh, indeed, AI can help us, and they will explain how. Right now, the we cannot predict. I mean, to predict in tsunamis is impossible, particularly before they happen. After they happen, many people say, I got told you so, etc. But before they happen, no. So it's as hard as predicting earthquakes. Now, once an earthquake happens, then it's within pretty much within a window of about 10 minutes. The warning centers in Hawaii or in Alaska or in Melbourne will have estimates of, uh, you know, they will be able to issue a tsunami warning. And, if technology improves further, we can have, I mean, we have the technology right now. They just, it's just not being utilized to have a really good idea how high the tsunami is going to be in different locales. Um, and when you have, for example, it depends where you are. I mean, if you're in Japan and you have an earthquake just off Japan, you're going to have about 20 minutes until the tsunami arrives. Within that period of time, it's very hard to make, real-time assessment of how high the tsunami is. But the same earthquake that, hits Japan, the same this tsunami that's generated is going to come to Hawaii, it's going to come to California, it's going to go to, maybe it's going to reach Central America. And, there you have, several hours, over 10 hours of propagation time. For California, you may have 12 hours. And in that period of time, you can do a lot of computations and you can figure out how big the tsunami is going to be. So you can have a really targeted tsunami warning. A targeted warning means something that, I'm going to evacuate this area only and not this area. Or, yes, we may have a tsunami warning for the entire Pacific, but I know that my region here, the tsunami is going to arrive, is going to be less than half a meter, so I don't need to worry, I don't need to issue an evacuation. Where artificial intelligence can help us is exactly because we have all of these pre-computed scenarios. We have run, I mean, certainly in my lab at the University of Southern California, we've run, thousands of scenarios. The next step of, for tsunamis in the Pacific and the Mediterranean, the next step is actually training, with machine learning, a bot, so that uh, it can be a useful tool for the warning centers to be able to have a very quick assessment of where the tsunami is going to impact and how high the tsunami will be.
Yes. And which country is notorious for the most tsunamis? Is it Japan or Hawaii?
Huh. Uh, probably what this is not a good you know the this is a competition of misery, who is more miserable. But I think the Japan takes the they have more tsunamis in Japan. And the problem with Japan, Hawaii in a way is a bit more fortunate because Hawaii gets tsunamis that come in from, Chile, from the South America, from Alaska, from Japan. It would get one from Cascadia, but there is time until the wave will get to Hawaii. So there will be time to issue a timely warning, to evacuate people, to do an assessment of the kind that I was telling you. How big is the tsunami going to be? What areas are going to be impacted? Japan there's no time for this. This is why when there is a big earthquake just off Japan, which is any earthquake that lasts more than 15 seconds, they issue the warning right away because you really do not have time to evacuate people. And even during the 2011 Japan tsunami, I've done a lot of field work there. I've talked to emergency managers in the areas where the emergency manager did not wait for the official warning, which came in about 3 minutes later, but actually used the natural warning, which was the duration of the earthquake. You're sitting there, you have a strong earthquake. Once it lasts over 15 seconds, 15, 1, 5, you know that this is strong shaking. Push the evacuation button, started evacuating the town. So those coastal communities and towns that were evacuated because the emergency manager took the correct action, evacuated right away at the first signs of a strong shaking, they had less percentage of people dying than in the areas where they waited for the official warning, which came, as I said, 3 or 4 minutes later, in some areas a little bit later. But even these 3 or 4 minutes, you can get a lot of people, out of harm's way.
Yeah, and why does Japan have the most record of tsunami and earthquakes? Because
It's a
from
it's a very good question. I mean, the entire southeast. I mean, in Japan, you also have subduction, and this is why in Japan you have volcanoes like Mount Fuji. It's a famous, volcano. You have other volcanoes. It goes down from the Kuril Islands. Kuril Islands are in the Kamchatka Peninsula. Kamchatka is Russian. If you think about the ring of fire around the Pacific, on that side it's the Northwest Pacific. You have the Kamchatka, which has a lot of volcanoes. Then you have a few islands that are the Kuril Islands, and then you have the Hokkaido and Honshu, which is the big island in Japan. So all of those are sitting on a subduction zone, which is on the other side. I explained the subduction zone on the East Pacific with the American plate going over the Pacific plate. Here you have the Japan plate going over the Pacific plate. So again, you have the same kind of a subduction going on, and you have and it's very active. You see, not all subduction zones move at the same pace. I mean, Cascadia does not move as fast as the Japan subduction zone. Parts of the Japan subduction zone move faster than others. Now we have fairly good measurements that we can tell that. Before, it was not easy. I mean, you have how do you measure the relative motion in the subduction? You can't. But now we have better measurements, so we can tell. And the answer to your question is that it's different rates of motion. The faster that the displacement and the deformation that takes place, the more frequent earthquakes you will get and the more frequent tsunamis.
Yes, and the 2011 earthquake tsunami as well was devastating. I mean, what made that event so devastating? Was it just the power, the sheer force of that earthquake?
Uh, it was the sheer force of the earthquake. I mean, the energy. It had a little bit less energy than Sumatra, but it was, it was a highly developed, industrialized area and, very densely populated. I mean, if you think about Sumatra, in a way, we were lucky. I mean, the areas that, the hardest hit area was Banda Aceh, which was 180,000 people died there. That was in the tip of Sumatra. But the rest of Sumatra was not, where the earthquake hit was not densely populated. It was essentially, uh, you know, uh, uh, there were no communities. If you go further up in West Malaysia, it was not as densely populated as as Japan. So the areas close to the epicenter of this huge event, they were not, other than Banda Aceh, they were not that densely. Uh, there were not that many cities, communities. You go to Eastern Japan, and it's community after community after community, and it's fairly, it's a lot of it's very densely. I mean, Japan doesn't have a lot of land because it has all the mountains. So people in Japan live along a strip on the west side of Japan, the west side towards the Sea of Japan, and on the east side where this earthquake was. So this is where people live, and this is and this is where the power plants are. This is where everything. I mean, all the communities are. So you have a tremendous exposure. So when you have a lot of exposure and you couple that with a huge earthquake, you get apologies, let me turn this off. So the exposure coupled with the hazard, have a huge hazard, creates a really big risk.
Yeah, it's scary. Yeah, I saw the footage of the tsunami in Japan. It was terrifying. What would you say, or what tsunami scenario keeps you up at night, Professor Costas? Like, if you had to predict, or just with everything that you know right now, with the Cascadian Subduction Zone and that fault line, that whole side of the East Coast is a ticking time bomb. But what's a particular event that could happen that keeps you up at night?
Okay. Um, Cascadia obviously is big in my mind, but I'll take you to another part of the world in the Eastern Mediterranean, where there have been, really big, there's another big subduction zone. There were huge earthquakes in 365 AD, magnitude 8.5 to 8.7. In a 1303 AD, again, estimated earthquake anywhere between 8.2 to 8.5. I mean, it's really earthquakes that when they happened 1,000 years ago, you cannot really, earthquakes are not measured, so you have to get some idea of the size of the earthquake from the historic reports, what happens. In the Eastern Mediterranean, there are now a couple of warning centers, but there is simply not enough public outreach. People don't know what to do. So even if you had a big earthquake, I don't think people would evacuate, right away. In Greece, there would be warnings because there is a wireless emergency alert called 1112, and I was instrumental in getting that along with a colleague, George Karagiannis. We were instrumental about 5 years ago in actually getting the wireless emergency alerts in Greece implemented. So there will be a wireless emergency alert in Greece. But what about Turkey? What about North, Egypt? What about Libya? What about the coast of Lebanon, Syria? It's going to be a nightmare. I mean, by the time, you see, because what I'm saying it's going to be a nightmare because propagation times are fairly short. I mean, you're going to have a wave that starts it's called the Hellenic Arc. It's a huge subduction zone. It's where the European plate rides over the African plate. Same story as in the other subduction zones. You're going to get a wave, and there will be a warning. And unless people know what to do, we're going to have a lot of people dying. I mean, all over the Eastern Mediterranean. So that is a scenario that keeps me up at night. I'm hoping that there will be, public outreach efforts. People will know, will be educated to evacuate right away. I hope there will be, tsunami signage leading people to evacuate. So it's something that's really worries me. And as I said, the one part is the wireless emergency alerts, which exist in Greece, but they don't exist in other places. And this needs to change. I mean, every single community in the Eastern Mediterranean needs to have a wireless emergency alert. So you will get on your cell phone, you're going to get a message. And actually, I mean, you cannot ignore it. I mean, the whole cell phone vibrates and gets you so that, that you are going to evacuate. And for now, as I said, this is only for in Greece. But we need to have it in the entire Eastern Mediterranean.
Yes, yeah. If you had the full attention of global leaders for 60 seconds, what would you say to them about being prepared for the next tsunami?
I would say it's a great question. It's a good question, James. Thank you. I would say educate, educate, educate. There is nothing like emergency preparedness, getting people to be prepared. And it's not just the people, it's the civil defense authorities. I mean, get them ready because we don't know. I mean, it's just a matter of time. We don't know what's going to happen. The longer the time passes between one event and the previous event, people forget. We really need to have, an educated population. We need to have a civil defense that's ready. There's really no time. I mean, when you have a few minutes until, even 20 minutes is a few minutes until the wave arrives. I mean, you need to have a civil defense that knows exactly what to do. I mean, there's not a moment wasted. And you need to be able to get, wireless emergency alerts out immediately with specific information, what to do. So again, it all boils down to education and preparedness, which is something that unfortunately varies around the world.
Yes, yeah. And what about in Australia? So I live in Australia,
Yeah.
and we're obviously notorious for our beaches
Yeah.
and surfing and things like that.
Mhm.
Have you done a bit of research, or what is the likelihood of potential tsunamis in the future hitting Australia?
I haven't done a lot of research myself, but I know that the Bureau of Meteorology in Melbourne, they are incredibly well prepared because I went back right after the Indian Ocean tsunami. I was there in 2000, 2 years later, and helped set up the Australian tsunami warning center. So I know that it is world class. Now. Uh, I don't know to what extent there is, public awareness. Certainly, tsunamis are not, as common in Australia as there are in Japan or in other parts of the world. But certainly, Western Australia is at risk from tsunamis that come in from the, from the Indian Ocean. Eastern Australia from tsunamis that would come in, maybe from New Zealand, from the Kermadec subduction zone. That's another subduction zone, or further north from the entire plate around Papua New Guinea. There's a lot of stuff going on there, in terms of earthquakes and volcanoes. So I'm pretty sure, without having specific knowledge, who does this in Australia, but I do have confidence um, in the warning centers, that at least there will be timely warning. I hope so.
Yes, yeah. And what role does coastal engineering play in tsunami risk mitigation? Like, can we really build against a tsunami?
Uh, uh, Yes and no. I mean, look at the experience in Japan. In Japan, they had constructed huge seawalls, um, all along the Sendai Plain, that's in central Japan. They were 3 meters high. They were overtaken by the tsunami in 2011. So they are constructing now seawalls that are 10 meters high. Uh, Partly because why they construct them 3 meters high? Because they didn't expect a bigger tsunami than that. And they have been through that again in Japan. I mean, there was an island called Usiri in the Sea of Japan, that's between Japan and Korea. Uh, and there, again, they had 3 meter high seawalls. Big tsunami in 1993. Then they I forget how many people died in Kusiri. I think about 200 people died in Kusiri, but it was a fairly small population, about 1,000 people. And the then they built 10-meter high seawall. They are doing this now in Eastern Japan as well. You cannot chase nature. Yes, sure, you can build, a fortress around Japan, around any area, but this is not the life that we want. I mean, can you imagine in at-risk places in Australia where we have beautiful beaches where people surf, someone putting in a 10-meter high seawall?
Yeah.
It's not going to. I mean, I think the best strategy is to have really good early warning systems and an educated population, so that people can evacuate. And I'm saying this because with the experience of Japan tells us that we're always chasing the last disaster. In Japan, they had the seawalls that were 3 meters high, because this is as high as the last tsunami that they had experienced at that location was. And they thought 3 meters was high enough. And sure enough, within, you know, uh, pretty much 2 decades after the seawalls are built, they're experiencing a tsunami that's 10 meters high. So they build a seawall that's 10 meters high. What's going to happen if in the specific location, suddenly you experience in a tsunami in 50 years' time or 100 years' time, that's 15 meters high? Remember, we're also going to have sea level rise, which is going to affect, interaction with seawalls in a different way. Again, you're going to have the same problem. What are you going to do in 100 years, in 50 or 100 years? You're going to build it, the seawall now is going to be 15 meters high. I mean, very soon you're not going to be able to see the sea at all. So we need a little bit more of holistic approach. We need to understand that, any person that lives close to the coastline, yes, we are at risk of tsunamis. I mean, they could happen anytime, but as long as we know what to do, there is pretty much always enough time. I mean, if you know how to recognize the signs of an impending tsunami, if there's a timely warning, I would say in the overwhelming majority of cases, there will be enough time to go out, to get out of harm's way, not really running like crazy and panicking, and just walking and getting out of harm's way. So this is where we need to go in and, calculate, in our lives, particularly if we live right on the coast, yes, our house might be destroyed, but as long as we are safe and we know what to do, this is what's this is what this is where we need to go. But as far as coastal engineering, come back to your question. Yes, there is a technology. We can have as big of a seawall as you want, but I don't think this is the best use of our societal resources.
Yes. What can the rest of the world learn from Japan, and how can we be ready for the next tsunami? What are some of the things if people were to see the tide suddenly go out, like that would be an indication of a possible
Yes, yes,
tsunami
yes.
coming in. I think there was a story of a little girl who I forget her name. I think it was Tilly or something like that, and she studied about tsunamis back in school, and she noticed the tide going out. It was very unusual, and I think she saved 10 or so people on the beach in
Well,
Thailand in the 2004 tsunami.
it
But
is. Mhm.
yeah, but what can people do and be better prepared for a tsunami if they were to be in a situation like that?
It is totally true, James. And we have another case like this, a little girl in the island of Juan Fernandez. That's the island of Robinson Crusoe. This is where
Mm.
Daniel Defoe wrote this famous book, Robinson Crusoe, about being cast away in this island, which is about you know, close to 600 kilometers east of the coast of Chile, sorry, west of the coast of Chile. So there, this little girl felt the earthquake and went in the middle of the night and actually rang the church bell. What had she done about this was in 2010. Exactly 10 years later, I was with my team in the Juan Fernandez, and we had actually given a lecture to the school that this little girl was going in. And so at the time, it was elementary school, and the kindergarten, elementary school, telling people what to do, etc. So she had heard someone that had been there and told them what to do in the case of if they felt a strong ground shaking, and she saved a lot of people. So this is the kind of things that we need. I mean, we need this. Where I keep coming back to education, just like the girl in Thailand, just like this girl in Juan Fernandez in Chile. You need people that can actually see the harbinger signs of a tsunami. What are they? I mean, if you're on the coast and you feel like ground shaking that lasts more than 15 seconds, why do we say 15 seconds? Because this means that, this is a strong earthquake that could generate a tsunami. So, or if you see a rapid withdrawal of the water surface or any other kind of unusual water motion. I mean, typically, and this is what happened in Thailand, people saw the tide was withdrawing and people could go in and try to see, the seafloor is being exposed. This was, extremely unusual. And yet people were sitting there trying to understand what was going on instead for running for their lives. So this is the kind of thing that you need to be able to recognize it. I mean, it's not hard to recognize a fast receding or a fast advancing tide. Anyone can do that. I mean, um, so people need to recognize that. And then either the ground shaking or the fast receding and fast advancing tide, and you move to high ground. We say typically, you know, 15, 15 meters high, 1.5. I mean, high ground means we can even go to to a building. But I mean, even if you don't have, or to a nearby hill. But the further away you get off the beach, the better it is. So you cannot wait. I mean, this is watching a tsunami is not a spectator sport. Once I mean, if you're on the shoreline and you feel the ground shake, it lasts over 15 seconds. That's your clue. You move to high ground and you wait for instructions from civil defense, or you listen to the radio, or just see what happens. And if
Yeah.
you're not lucky,
And
you see you know, the wave
and
coming in.
how fast can a tsunami travel? Like I heard it can travel as fast as a jet plane. Is that
Look,
correct?
yes, but this in the deep ocean, James, not on the shoreline. In the deep
Ah,
ocean, the tsunami speed depends on the depth of the ocean. In the deep ocean, because we have a large depth, the tsunami will move 400 or 500 miles per hour, which is the speed of a
wow.
jetliner. Once you are on dry land, the tsunami slows down considerably. It will move at essentially the speed that you see, a wave, a breaking wave, or a surfing wave move. So that's the speed of a tsunami when it reaches the land. I mean, it slows down, but I mean, this is when it's in the water. Once it hits the shoreline, it speeds up. So And I want to make sure that people do not get, because we've had this happening in the past. People see, a wave coming in, and they think I can outrun this because they're used to, surfing waves, and they see, breaker coming in, so the breaks down, and there, it has, very small, run up, washes up, the washes up on the beach, and say, this is. We've seen this before. I've seen waves like this. I have experience with this. A tsunami is very, very different. Once it hits that, it will suddenly accelerate. So, it may reach from a speed that will go in from, 3, 4 miles per hour. It might get all the way, to 10 miles per hour. So, you need to move, fast. You cannot wait. And there's a lot of people sit there, they want to take pictures. It's totally the wrong reaction. Go go to go to high ground and take your cell phone there, your camera, and take the picture from high ground, not from where you're sitting, because by the time you can take a good picture of the tsunami, you're a goner.
Yeah.
You're not going to have time to evacuate. If you can see the tsunami and take a good picture of it, this is going to be the last picture you take in your life.
Yeah. And what were some of the early warning failures that contributed to such the high death toll in the 2004 Boxing Day tsunami? You did mention that there just weren't a lot of early warning tsunami.
Yeah,
Um,
there were no tsunami warning centers, and also in the other thing that happened, that they hadn't underestimated the tsunami in the beginning. You see, um, computers run. I mean, they analyze the signal, and it's automated. So they had put a cutoff to about 3 minutes of the shaking. So they analyzed, the first 3 minutes of the signal. But the earthquake lasted for 6 minutes. But they only analyzed 3 because this was the automated cutoff. Think of it, like a seismograph signal comes in, and there's a cutoff, a window that someone cuts it off at 3 minutes, says, "This is my earthquake. Let me go and analyze it." So the initial estimate was that it was of the order of magnitude 8 instead of a magnitude 9.2. But then the wave kept going. And if you talk to the people in the Pacific Tsunami Warning Center, that they were uh, right there, I mean, they'll tell you that they look at it, it's a huge earthquake, and then someone glances over, and this thing keeps going, and they don't believe it, that it keeps going, because this was the first earthquake that happens in, when the shelter was operational, etc., and they had to do, this analysis. They had not seen this before, so it keeps going. So they have to do the analysis by hand, pretty much by hand, by computer. But someone, a programmer has to sit there and actually, versus using all the automated programs that they do this. So as they're sitting there, they say this. So um, by the time they have the complete analysis and they can analyze the complete 6 minutes. Um, it's not actually complete 6 minutes. It keeps on going for much longer, but the 6 minutes had enough information. They don't have the tools. They managed to get an estimate. It takes, several. Uh, I forget how. I mean, the first estimate that was about magnitude, 9. It probably happened within an hour or two. But to find out that it was a magnitude 9.2, that took days, literally, because nobody was set up to try to analyze the signals from this, giant earthquake. So this was one of the reasons. But even if they had understood it at the time, there was no infrastructure. I mean, what would you do? They were set up in, going back 20 years ago, sending faxes. A fax arrives, somewhere in Jakarta. Oh, well, you've had a big earthquake there. Well, they know this. There might be a possibility of a tsunami. Where? The infrastructure was not there. I mean, the connection between the warning center and what we call the last mile. How do you implement the warning? This is why the wireless emergency alert, and and I will mention again, this the was implemented in Greece back in 2018. I mean, it started in 2019, but the first warning went out in 2020, and it was the first time that outside Japan, a tsunami warning arrives before the tsunami arrives, which is exactly what you need. And this was the wireless emergency alert the 1112 system, which exists in Japan, but it didn't exist in 2004 and still doesn't exist in many locations. We may have warning centers, but the last minute dissemination of the warning, this varies very, very much by location. I mentioned earlier the problem in Europe, in Eastern Mediterranean, that there are many countries that they don't have wireless emergency alert systems. So even if they get the warning, how do you disseminate it? Radio, television, messaging. That's not the time to try. I mean, to try sending messages, but they should. So it's something. There's a lot of work to be done, James. A lot of work
Yes.
to be done.
Yeah. And I was reading too that with the 2004 Indian Ocean tsunami, they had one of the largest mortuary setups. Bodies were just piling up. And,
Wow.
when a tragedy like that happens, a lot of disease and decay and decomposition of the bodies, and it's pretty and I mean it would have been very hot too, and I mean what's the risk of disease and sickness after a catastrophe like
Huge.
that?
Huge.
Yeah.
We were very lucky in the Indian Ocean tsunami. In the international community was mobilized very, very, very quickly. Same thing happened in Papua New Guinea, and this was a time in 1998. It was a much smaller disaster, but this is where Australia basically, within 2 days, I mean, had set up in field hospitals, basically created an airstrip and had, help coming into North Papua New Guinea, and was instrumental in not having, more people and not spreading, diseases. Because what happens is, particularly in areas where you have high temperatures, the tropics, bacteria grow very rapidly. You basically lose all of your freshwater supplies, or the ones that are close by, because they're damaged by the earthquake. I mean, you lose your water treatment facilities if you have them. So all of these get flooded. So imagine having, I mean, a place like in Bandache, where you had all the water, whatever water, rudimentary water treatment they had, all of that gets flooded. Fresh water. I mean, there's no fresh water. What kind of water are people going to drink? So it becomes a very complex, very complex catastrophe. This is where comes back again to the whole idea of preparedness. And it is not just preparing in terms of the warning, but preparing for the aftermath, preparing for the crisis management. And this is something that the world community, I fear, has not paid enough attention to. What happens the day after? Sure. Now, I'd say, we have warning systems for most of the world. I don't think we're going to be caught with our pants down as we were in 2004. There will be some, rudiment. For most places, there will be some kind of warning, whether it's heeded or not. As I said, I worry about North Africa. I worry about, East Africa, in the Indian Ocean. What's going to happen? Many places, in Myanmar or in Bangladesh. I mean, if you ever get a wave that reaches up to there, but there will be some semblance of warning. But what about the day after? What about 2 days after? I mean, when you had this huge flooding that has, destroyed everything, um, you know, how are you going to control how are you going to do disease control, etc.? So these are things that people haven't really thought about. James, we keep going. Such a fantastic discussion, but it's the time that I need to I have class very, very soon. So,
No,
need to,
all
I'll take
good,
one more
Costa.
question, James, and then I'll
Yeah.
go to class, or else my student. I should have had this in front of the students. I should have thought about this. This would be so
Yeah,
great.
it's
Can you
I
imagine having a
really I really
podcast?
enjoyed
We
having a
should do
chat
that
with
next
you.
time. Have a podcast in class. And
I
I'll
think
have
so. I think that'll work really well. That'd be
wouldn't
fun.
that be? And then you can talk to students as well, ask them questions. So
Yeah.
that would work great.
Yeah, and I'd love to talk to you maybe next time about the Eden fires as well. We can
Sure,
talk
sure,
about that
yeah.
another time, but
And
I
that's
could
about
talk
the
to you.
crisis
I could talk
crisis
to you all
management.
day. Fascinating, obviously, learning about tsunamis. But thank you so much for your time.
Okay. Thank you, James. It was wonderful.
Thank you.